In this lesson, we are going to be talking about the nature of roots. In the previous lesson, we were using the quadratic formula to determine what the roots were, but in this lesson, we're going to be talking about the different kinds of answers that we were getting. If you remember back, I did say that we would be discussing why some questions we got 1, 2, or 0 roots, and this is where we're going to be doing that. So quadratic equations can have 0, 1, or 2 solutions. I have 3 grids drawn right here, and I'm just going to be drawing you some examples of what each of those would look like. So any parabola that passes through 2 times is going to have 2 roots. So I could basically draw anything, and I have 2 x-intercepts here. So this is an example of something that has 2 solutions. Now I am just going to draw another one just so you could see it doesn't have to be facing up. It could be facing down. That also has 2 solutions right here and here. The next example is an example of 1 root. This example is always going to be a parabola that has a vertex right on the x-axis. So here's one example, and again, I'll draw another one in green here just so that you can see. That doesn't quite hit, but you get the point. So this is an example of 1 solution. I don't know why I wrote solutions there, sorry about that. The third example that I'm going to be talking about is a parabola that has 0 solutions or 0 roots. So a parabola that's not going to cross the x-axis at all. So one type of parabola would be a parabola that faces up that is higher than the x-axis, and another one would be any parabola that faces down that is lower than the x-axis. This doesn't touch my x-axis at all, and so it has 0 roots. Sometimes a question will ask us the nature of the roots or how many roots they are, but it doesn't want to know what the roots are. If that's the case, if we're just wanting to know how many roots there are, we can use something called the discriminant. So the discriminant is b squared minus 4ac. That might seem familiar to you. That's because that's just the expression that's underneath the square root in the quadratic formula that we learned in the last question. So we have 3 options here. Option 1, if b squared minus 4ac is equal to 0, then that means that we have 1 root. If b squared minus 4ac is less than 0, so if it's a negative number, then that simply means we have no roots. And if b squared minus 4ac is greater than 0, that means that we have 2 roots. If our quadratic equation is already in vertex form, then we can just use the knowledge that we previously have of looking at that and knowing where the vertex is and the direction of the opening in order to decide how many roots it has. We will be discussing a couple examples of using the discriminant and just looking at the equation on the next couple of slides. This first example that we're going to go through is an equation that's already in vertex form. So we know that it's in vertex form because we see a couple of key features. We can clearly see our a, our h, our k. We can see some brackets with the exponent 2. So right away when we look at this, we know that this equation has a vertex at, change the sign, positive 5, 3. So I'm just going to picture this right here. I know that I have a vertex at positive 5, so over 5, and then up 3. Now I also know, because I have a positive a value or a positive 2 right here, that this parabola opens up. What I can clearly see is that since this parabola opens up and the vertex is above the x-axis, there's no roots. There's no way that it's going to be able to cross the x-axis all the way down here. So this question, without even using the discriminant, I can just look and see that there are no roots. When I look at this example, we'll just call this example 2. This example is not in vertex form, so this equation is in standard form. I could put it in vertex form and then check my roots from there, but that's a lot of work completing the square and doing all of that. So what I am going to do is just use the discriminant. So again, we're just going to remember my discriminant is b squared minus 4ac. So when I'm taking a look at my equation, I have my a equals the number in front of the x squared, so the 5. My b is the number in front of the x, so my 3, and my c is the number that's alone. So I'm going to go ahead and I'm going to plug in this information. So b squared, so 3 squared minus 4 times a, my a was 5, times c, which was negative 7. 3 squared is 9, and then I have a minus, so minus 4 times 5, which is 20, times negative 7, so a negative 140. Now I really have a 9. These two negatives will make a positive, and I'm going to get 149. If we think back, we know that any discriminant greater than 0 has 2 roots. So therefore, this formula, or this quadratic equation, has 2 roots. In our third and final example, we're going to be solving for k. So in this expression, kx minus 10 equals 5x squared, we need to find the value of k that would give us only one solution. So again, we're going to think back. We know that when our discriminant is equal to 0, that gives us one solution. Now, if this question was worded a little bit differently and it said, find a value of k that has no solutions, everything would look the exact same, except instead of equals 0, we would be writing a less than 0, and we would just carry that less than down for this entire question. Now, before we can start, we do need to rearrange this equation. So because the equation is not already in standard form, it does need to be rewritten. So I'm going to be taking everything that's on the left-hand side here and moving it over with the 5x squared. So I'm going to be getting 5x squared, and this kx is going to become a minus kx, and then this minus 10 is going to become a plus 10. And then it will equal 0 exactly like what I want it to. Now I can very easily see my a is 5, my b is negative k, and my c is 10. So I'm going to be going ahead and plugging that in here. So my b was negative k, so negative k squared minus 4 times a, which was 5, times c, which was 10. Negative k squared is just k squared. And then a minus 4 times 5, which is 20, times 10, which is 200. So I'm going to be getting k squared equals positive 200 because I'm going to be taking this minus 100 and moving it over to the right-hand side. And then I know that if I want to solve for k, I need to square root both sides. And I'm going to get k is equal to plus or minus the square root of 200. Now we can go ahead and we can do that on a calculator. It will give us a decimal number, or we can just leave it like this, and that is a perfectly acceptable answer. I do need to make sure that I'm including that plus minus in front, because if you think about what answers you're getting, a negative times a negative, or a negative squared, will give us a positive. So that's exactly why we need to include this plus minus.